So JBL 500 series XT. This is a 515 XT. It's one with the complete heatsink. This has been removed, but you can see there's the consumer. If you've got one of these, that's what it looks like. And this whole module, if I turn this over, you're familiar with all the inputs and everything else, but this is more an aid to help you remember how to put it back together. So turn her over, and there is the electronics. And this is just a, ignore that wire, that's just a ground point wire. I'll just take that off actually in one moment. Yeah, so normally in situ there's a metal can sitting over the top of this to protect this from the vibrations, and also to make electromagnetic shield, more electrostatic shield, EMC shield around the electronics. And down this end you've got the mixer input board and power control. I'll zoom in a little bit more so you can see better. And then a ribbon cable carrying power back to this mixer board, and also the actually analog signals, differential analog signals in an HF and an LF channel. So for the bass driver and for the tweeter treble driver, there's two separate sets of signals going up here. So this is the low frequency amplifier Class D switching control unit, which drives these FETs here. So this part here, all of that is the low frequency channel, and the low frequency Class D filtration electronics are over here. It's just a passive filter. And yeah, I've just noticed this has been clobbered in freight. There's a dent in this capacitor. That's what I'm pausing about. Yeah, so here it is, and here, this is the HF treble amplifier. The treble amplifier for the tweeter driver is a lot simpler. It's almost straight off the manufacturer's data sheet, where this is more of a proprietary implementation of a Class D amplifier. Not a very good one, it has to be said. But if you've taken this thing apart and you're putting this board back on, there's some things that you need to know. If you look down the side here, I don't know if you can see this, but under here is an insulating sheet. That's got to go back on the way it came off. And underneath these transistors, you can't see it, and underneath the end here you can see there's a pink tab. Yeah, can you see that corner of that pink tab? That's an insulating tab, silicon tab, which goes between the HF output driver chip and the heatsink. So that's insulation, and underneath these are insulating washers. So there's a big insulation pad. There's a bunch of transistor packages on the back of the board. You can just see their legs poking through here. There's some linear regulators as well here. There's a 15 and 5 volt linear regulators, plus and minus 15. And then you've got the Schottky rectifier diodes on the output from the power supply to provide your roughly nominal plus or minus 20 volts, which is smoothed by this. Okay. Now, note the location of these things. These are like reinforcing bars, because these screws go through to the heatsink underneath, and they hold these spots are immediately above the body of the transistors and the electronic devices, which are dissipating heat when you're driving the unit. And obviously the heat goes into this metal heatsink and out the back. So if these aren't correctly placed, firstly there might be a cause. If you don't put them in at all, you're going to end up with the board will just blow up and down, and the transistors won't be held down onto the heatsink. They'll overheat and you'll probably have problems. If you put these on the wrong way around, they can short out on the board underneath, so you have to make sure they go correctly, and you just tighten them down pretty tight onto the don't go mad, but you know, hand tight onto the board to give pressure, so it pushes the board down on top of the transistor packages, and then between the transistor package metal heatsink on each package, which is facing downwards, there is a silicon pad underneath, right? So then we make sure that silicon pad goes back in, and it's good practice just put a little spot, because the pads have this displacement type arrangement where when they're tightened down, the silicon material, heat conducting material in the pad kind of displaces, and when you take this off you'll see imprints of all the transistors in the pad. And of course, if you put a slightly different transistor back in, because say one or a heat or an regulator chip is blown, then you won't not necessarily get good thermal contact. So it's good practice to put a small dab of heatsink underneath each one on the metal case of the transistors before you bolt bolt the board back down onto the pad. Okay, so a little dab of white heatsink compound, and when we repair these, we supply the board back with little dabs of heatsink in a tube, in a syringe usually, just a small spot on the back of each of these 12 components there, to improve the heat transmission conductivity of the heatsink, so the heat dissipated, when the energy dissipated in the devices gets into the heatsink as efficiently as possible. And the same with this. And then over here there's the power supply switching transistors, and again you've got a metal bracket over there. Note the way around it goes, and note that this one isn't quite perpendicular to this heatsink. It's like you screw round slightly. Actually it should be in line with the edge of the board, i.e. perpendicular to this. You can see it's not quite perpendicular, it's screwed round. When they tightened up it's moved. Well, it should be, it's not too bad, but I have seen them well turned around. And so, you know, the ends of the dots aren't, the depressions, and these aren't actually, more or less, not really on top of the body of the transistor underneath. So watch out for that. And then you've got all these screws, and there are slightly different screws as well. And I advise you to, if you look over here, you can see these are a different thread of screw, they're a different length screw, these are all standard screws. But I'd advise you to take a few pictures before you take it apart, is the best bet. If you're going to send it off for repair, or even if you're going to repair it yourself, just take a few pictures and have a look when you put it back together at your pictures that you've taken. We frequently get them packed up and sent off when this crystal is broken off. So if it's been handled badly, that's very delicate. It's near to the edge of the board. It's a shame they didn't put it in here somewhere away from the edge, because it is a vulnerable component. It's a 16 megahertz crystal, which provides the clock for the Class D low frequency amplifier section. That's about it really. So be sure to put all the screws back in. Be sure to get these metal parts in the right way around, and all the screws on top of them. Be sure to put a little dab of heatsink compound under each of the metal body on the base of each transistor and component and regulator before you screw the board down. Be sure to make sure there's a silicon insulating pad on the metal work here. Be sure that this insulating pad here, this anti-spark over plastic sheet, is in position under there. If that's not there and you get a mains transit, you get spark over onto the heatsink. Not good. Be sure to make sure that you put this back in position. You can also see here, actually, if I zoom in a bit further, underneath this screw here is a plastic top hat to insulate the metal part of the heatsink of that chip. So make sure the actual plastic top hat goes under there, because this screw is into the heatsink, so it's at ground. Must not contact the metalwork on here, otherwise it goes kafooey. It just won't work actually. So be careful of that. Make sure the little plastic top hat's under there, and if you've lost it, you're going to have to find another one or buy one from eBay. You can buy them online, or at Radio Spares or Farnell. So there you go. Make sure your screws. Oh yeah, this insulator is an additional insulator to insulate the case of these caps. These are the high voltage DC raw rectified mains input capacitors. So make sure that pad, sometimes that pad's missing, and when you put the metal case on the top, the metal case almost rests on there, so you could end up with a short situation. So make sure that if these have been changed, make sure you have a significant insulation between the top of the cans and the actual metal can that goes over the top of this. Alright. Other issue here is with these Spade connectors. These are okay, these are good Spade connectors. speed. Right, I've seen 515s from the factory. If you look on the mains plug or the main socket, you can see it's got the smaller Spade connectors on there. They're actually quite a bit narrower, or not as wide. They're the same thickness, but not as wide. So if you get the correct Spade connector to go on there, it will not. You can see these ones here are much bigger. They're a much bigger size. They're the next size up. I forget it's 6 and 8 millimeters, is it? I can't remember, but you'll know, anyone that's done any auto wiring or used Spade connectors knows that there's 2 different sizes. And I've seen these units come in where at the factory they've used this big one on both ends of the loom. Okay, both ends of the loom, stupid. And what you actually end up with is a very loose fitting here. Very loose. They almost come off, and sometimes I've even had speakers where they've just dropped off because they've, some Chinese workers just shoved them back on, carried on working, no problem at all, and produced some Chinese excrement rather than certification for Europe. So yeah, look out for that one. Make sure the loom has got a good tight fitting Spade connectors, and also that's also true, more than true, for this abomination of a loom. You can see this thing when you put your speaker back together. You've got this. Let's zoom out so you can see it. I'm sorry it's a bit shiny. This is just a bit of a rant to make sure that people know what they're doing. You've got the loom with the mini fit plug, taking the power off to your speakers, and then you've got these horrible crimps on the end. Okay, got these 4 crimps that go to the HF and LF drivers units, tweeters and the bass drivers. Now, I've also seen speakers where these have literally just about hanging on and even dropped off. When you put these back on the speaker, these are the bass ones, or you can see you've got a big one and a small one, okay, which is supposed to indicate polarity, but it doesn't really. But you should look on. There's a document on the JBL website that tells you. It's got the schematics of this loom and also shows you where these wires go onto the bass and treble units. I've had speakers come back. They said, "Oh, the amplifier's not working." And I said, "Well, okay, we'll send the whole bloody speaker and let's have a look at it." And they've got the bass connected to the treble, and the treble connected to the bass. And if you do that, it'll just melt the treble, the tweeter coil, the voice coil in the tweeter. So make sure you know which way round they go. I've got a bit of a mental block at the moment. Do I have to refer to the diagram or not? No, I don't actually, because this is the LF drive. That's the LF drive. If I plug the LF drive into there, plug the cables in, LF goes to there, goes to there, goes to there. So these wires, the green wires, nice green ones, they're the bass unit, and the blue ones are the treble unit. And actually, if I look on this speaker I've got here on the bass driver, the Spade, these are different sizes, look, but yeah, they are different sizes, so they will go, I'm showing them over there, so I'm looking, so they're a different size Spade. There's a big one and a small one, and it goes onto the bass drive unit. It's got big and small, but make sure they are a very tight fit. They are prone to being very loose and even falling off during performances. And on mine, I'm in a band. What I did, I cut round these, took the insulation off, and I soldered them onto the terminals because I wasn't really happy. Because if you think about this, the bass driver is a 2 ohm unit, and any 0.1, 0.2, 0.3 of an ohm on that connector, because it's not fitting properly. They're not gold plated, not special, not even very good, but I soldered mine on because I just don't trust them, frankly. But it's up to you at the end of the day. But whatever you do, when you put these back onto the drivers, make sure they're a really tight fit, and if they're not, you can just squeeze these up with a pair of pliers like so. Just put them in the pliers and give them a very gentle squeeze, and you'll see them close up, and gently, bit by bit, close them up a bit more until they're absolutely a nice tight fit on both the driver units. So here's a tweeter driver unit, and again you can see you've got the big one, the biggie, and the small one. And then if I try this on there, look how loose that is. That is just ridiculous. Look, this is a speaker from a customer that's just come in this morning. Look how loose that is. That's like a, well, I was going to say a prick in a shirt sleeve, but it's certainly like tossing a banana box to the street. It's terrible, and that will cause you problems. So you want to give that a nip up and tighten it up. And I say on mine, I've soldered them on because they don't really need to come off. And why risk it? Why not have a damn decent connection? Because any bad connection on the base side, if you lose drive, you suddenly, the power that's being created is reflected back into the output stage, and it'll blow the output stage up if you've got a bad connection. You can demonstrate that by disconnecting the load and running it, and you can see the heat with the heat camera. You can see the heat building up in the transistors. So yeah, I mean, that's straight off very bad. Let's try the other one, see if it's any better. Yeah, same again. See, no good at all. Not very good. When you consider this is a 4 ohm unit and this is a shitty connection, and this is tin, don't forget, this is tin plated, and if you get a small electric field generated around it, then you can grow things like tin oxide can form, and then quite often, especially on the old logic components, they had tin plated pins, and then yeah, I decided to add this in because this has got to come apart anyway because of this damaged capacitor. So to put it into context, what I told you in the first part of the video, this is the second part that shows you the parts underneath that you shouldn't forget. One thing I didn't mention before was that as it leaves the factory, there is a star washer underneath this position and this position below the metal heatsink. This thing. Okay, below the metal heatsink there's a star washer. I assume it's to make the heatsink make contact with the gold pad. This is gold plated, these boards. I don't think in reality it probably doesn't do anything at all, but it's there, so if you want to put it back as it's intended by the designer, you can. Obviously this holds a lot of charge. It's there's a voltage doubler circuit, so whether you're running on 110 or 220, 230 mains, you can get 300 and 350 volts across these two capacitors underneath. So when you take this off, they may well still have significant charge on them. Depends how quick you are, but don't take any risks because it can make you jump, at the very least make you jump. Taking the screw out here, look, with the top hat. Here's the top hat I mentioned. You can see a better view of the little toppy hatty thingy. There it is. Oh, there it is. So make sure that goes back on the HF amplifier chip. And then you lift it off. All the screws have been removed, obviously. Just grab hold of it and ease it free. And then you can see the silicon pad here underneath the amplifier chip for the HF. Another silicon pad here for the power transistors for the switch mode power supply. Insulating pad thingy-bob here to stop the flashover from the power supply and to provide some dielectric between the metal casting and the pins and protrusions from under the board. And then on there you can just about see this, can't you? I think you can. Can you see that? You can see that, can't you? You can just see the impression of the transistors on there. That's the impression of these two transistors on the back of here. These things that have been pressed into the sill pad. It's called this thing here is called a sill pad, silicon heat transfer pad, insulating but reasonably good conductor of heat. And actually, if you feel that, it does feel cold, so it means it's sucking the heat out of my fingers, baby. And then we've got this one here. Look, and this is the cluster of regulators and low LF output transistors. These four at this end, the LF, and if I just peel that off gently, you can see, oh, it's like peeling off sunburn. So gets me that. But you can see that's the displaceable silicon. It extrudes the silicon compound out. You want to keep that clean. Don't get it fluffy. Don't get any bits of dirt in it if you're going to have it work on this. Of course, when you put these back, they won't be in exactly the same spot. So what we do is we provide a little tube of silicone, and you put a blob of silicone on the back of each one of these before you put the pad back on. And obviously, These are insulated gate FETs at this end, but these aren't. So you need to have this pad in position, otherwise when you turn it on everything will just be shorted to everything else and it'll just be a complete shorty disaster. Okay, so I just thought I'd give you a video showing you the back of this thing. Yeah, I hope you found that interesting. Meme again. And another thing, just had one back from a customer. This resistor, they've been taken and putting a screw in or whatever, or in package or shipping, I'm not sure which, but there's a resistor bend over and pushed right down top of the high bandwidth differential input FET driver. Well, it's a gate driver actually. But yeah, and it's a wire wound, and as you know from a wire wound is a resistor, but it's also a coil. It's also as the current fluctuates through it, it makes a magnetic flux, and this unit was cutting out at high volume. The base was just dying on it, and believe it or not, it's due to this resistor being pushed down right on top of that chip. So yeah, when you put this back in, you can see they put some silicone on it here to keep it up and away. Make sure it's not squashed down onto the board. It's supposed to be standing proud like that. You see that? Can you see that? There. Yet another problem caused by a very nice customer, and this one's been pushed over as well, but that's not so important. Alright, okay, well that's it. Make sure this is standing up on its legs and not flattened on the board. Cause you problems.